Hey, everybody. Welcome back to the Doctor is In podcast. I'm your host, Dr. Nadia Sabeh, president and founder of Dr. Greenhouse. Today's episode is part of our special series, What Plants Crave from Technology, where I'm interviewing technology providers, developers, and building designers about the unique technological needs for growing crops indoors and in greenhouses. Today, we're going to put a little spotlight on greenhouse glazing. My guest today is Nico Augsberger, Director of Sales for Iyris, formerly known as Red Sea Farms. While at Red Sea, Nico helped develop and test new greenhouse technology specific for hot desert climates, including a desiccant-based cooling system and a new glazing material that blocks infrared radiation while transmitting PAR light into the greenhouse. Prior to working at Red Sea Farms, Nico studied air filtration for evaporative cooling systems as a postdoc researcher at KAUST in Saudi Arabia. We're going to talk cooling, which is a topic very near and dear to my heart. So, Nico, thank you so much for being on the What Plants Crave podcast. I am really excited to talk to you about greenhouse technologies specifically developed and used for hot climates, and also that can be used on low and mid-tech greenhouses, right? We're not just air conditioning and creating this really high-tech greenhouse to be able to grow in these challenging environments. So yeah, Nico, thank you for being on the podcast.
Pleasure, Nadia. Thank you so much for thinking of us and me. I'm really excited for the conversation. I think every time we talk, I learn something new, so I expect this will be no exception. And I love the fact that you pointed out technology for the masses, not just for the highest tech growers in the market.
So let's start with glazing. Why is greenhouse glazing important?
Well, it's the first filter, right? So it's a filter of light before it interacts with the plant, right? So plants need a few things in order to grow, those being nutrients and water, light and CO2. So light is a big component in that. And glazing interacts with that radiation coming off the sun prior to hitting the plants. So we have the ability to technify that glazings or that covering material in order to manipulate the light before it hits our plant. So we can like I say, manipulate that part of the environment for an ideal environment, or create an ideal environment for the plant.
So what are the important properties of a glazing material? Obviously, I mean, it's transparent, so we want to let light in. But what should greenhouse growers be looking for in addition to light and in addition to light?
So great question, Nadia. So when we think about light, it's a broad spectrum, right? So traditionally, greenhouses were designed to maintain heat, as we know, the greenhouse effect, right? And so that concerns a part of the radiation that the plants don't see. That's the long infrared. So depending on your geography, depends on how you want to spec your plastic. So the critical components to a glazing, or properties or characteristics, would be number one, transmission, which you touched on. Number two would be diffusion. So how that light, when it enters, how is it spread across the environment? Another would be its thermic properties. So is the film or the glazing designed to cool your greenhouse or maintain that heat? And so there's different additives that you can add during the extrusion process of the glazing that helps you achieve those goals.
So what are some of the glazing materials that are available to growers today?
Yeah. So when we think about glazing materials, right, we're talking about covering crops. And in protected agriculture, where you are covering your crops, there's a wide range of technologies that you could consider glazing. You could go as far as considering a shade net, a potential glazing. So that's a covering that interacts with light and the environment before hitting the crop. So going from kind of low tech to higher tech, I would categorize it as shade nets and shade screens. Then you have polyethylene film, which is probably the most used in the market when it comes to protected ag. Then you have stuff like polycarbonate, which can be, single wall and corrugated, or it can be dual wall to provide that extra insulation. And then you have even higher value products such as acrylic, which offer certain benefits but come at a cost.
What is the trade-off between light and the thermal properties? You mentioned, right, that the greenhouse effect, that is a benefit in especially cold climates, right? And where maybe greenhouses were first developed in the UK and then spread through Europe and Canada. And so, letting that sunlight come in is actually beneficial for heating up the greenhouse and reducing heating costs and heating energy use. Um, but, in hot climates, what is that trade-off between light and heat?
So I really like where you're taking the conversation, Nadia, because that's exactly what we're trying to do at Iyris and Red Sea with these photoselective materials, is exactly separate what is light and what is heat. So I think it's good to define that at this point in the conversation. And when we on Earth experience solar radiation, we experience the entire light spectrum, right? And so in horticulture, what the plants are really craving is the photosynthetic active radiation, right? What we know as PAR, which is from 400 to 700 nanometers traditionally. And beyond that, which actually accounts for 50% of the solar radiation, is the near infrared. The near infrared is essentially invisible to the plant and actually generates heat. So when we think about hot climates where we have an excess of radiation, we're not necessarily looking or fighting to get that extra DLI. It's actually controlling radiation while maximizing the productivity within a controlled environment. And so traditionally, to reduce temperatures or stress within that controlled environment space, you tend to lean on shading technologies. Now, that could be retractable screens in very high-tech greenhouses. That could be a shade cloth that is manually installed when radiations are high during the summer, or that could be something like chalking paint, which gives you that flexibility where you can apply it or you can take it off. The drawback or the separator between what we're trying to do is add photoselectivity to the mix. So not just reduce the entire radiation that's coming into the structure or the controlled environment, but separate the PAR light from the NIR. And so traditionally, to reduce temperatures, you're having to quite literally shade. And what we're trying to do is actually a false sense of shading. So we're reducing the near infrared while protecting the PAR light.
I mean, that's interesting because, when I am consulting on how to cool a greenhouse, usually shade is, the last resort, right? Because we want to let as much light in as possible for yields and for productivity. But it can get just so hot in the greenhouse that you have to do something. Otherwise, it's going to be, 90, 95, 100 degrees in the greenhouse, especially, in the Sun Belt region of the US. So, what do you have left? Block some of that light. And unfortunately, there's not a lot of photoselective shading systems available. So you end up blocking everything. And yes, it can diffuse, right? There's shading materials that can diffuse that light. So at least you have an even distribution of what you do bring into the greenhouse. But you are ultimately reducing, the full spectrum of light, right? To keep that infrared out.
Exactly. I mean, growers in hot climates are essentially adopting technologies from Europe, right? And
Mm-hmm.
that's where we're seeing the birth of different ways to manage heat is because the consultants, the main consultants in these large markets, even take Mexico, they mirror what Europe is doing. And so they're left with these high transmission films or glazing materials that then they have to manage for their geography or their crop. So
Yeah.
what we're trying to bring is essentially another tool which we say removes heat without shading. Of course, there's a bit of shading, but playing with the spectrum a little bit to maximize that environment and minimize the stress.
I mean, before we get into the SecondSky material, I mean, with those available glazing materials now that you mentioned, polyethylene and glass and polycarbonate and acrylic, I mean, is there a material that you would recommend for a hot climate, of the conventional bucket of materials, and ones that you would tell growers to stay away from?
So it's a great question, and it depends on the geography really and the
Mm,
resources available, right? So and the goal. If the goal is to have the most controlled environment, you would go towards an acrylic, or in hot climates, an acrylic or a
yeah.
PMMA, with a cooling system, have evaporative cooling, have retractable shade screens, and automated systems, hydroponics. You can technify it as high as you want, but that's not necessarily the reality for every grower. So a lot of what we do is reinstallment of technologies to existing growers. So we like
Sure.
to take a good look at what they're doing, what their pain points are, and optimize the solution or tailor the solution to a specific crop, to a specific geography. In terms of high transmission, and if you want a cheap product, polyethylene would suffice. The drawback is that it has a very short replacement cycle. So typical films are guaranteed for 2 to 3 years. And so there's an economic benefit on the front end, but you're having to replace that film. You're producing a lot of plastic waste. So it comes with its own set of drawbacks. Something like a polycarbonate, which is very, very common in North America, gives you some added insulation. So if you are in a more northern climate where, yes, you have warm summers, but you're also worried about the winter, provides some of that buffer for the grower. So I mean, it really depends, but plastic coverings I'm seeing give you a little bit more flexibility and in adding additives and playing with that light specific to your crop. So while glass houses have their benefits, they provide a lot of light for the crop. In hot climates, it's you're gonna have to add some other things to be able to deal with that level of radiation in the greenhouse.
Thank you for saying something about glass, because if you didn't, I was gonna to ask you. And yeah, I usually recommend against glass in hot, sunny climates because it's opaque to that infrared radiation, right? We want it to escape. We don't want to trap it in our desert climates. Great for the north, right?
Exactly.
But for down south, not so ideal. I do want to ask about acrylic. You've brought it up a couple times. I don't see acrylic very often in North America. I'm curious your thoughts on acrylic, what you like about it, why you would consider that part of the mix for growers here.
The real only comparison to acrylic is polycarbonate. I mean, acrylic is more expensive than polycarbonate, but you can't really compare acrylic to a polyethylene film. Acrylic is the closest thing you can get to glass without it being glass. So you still have a plastic covering that you can add diffusion to. You can add thermal additives to. You can play around with it a little bit and still have high transmission that lasts for a long time. So acrylic can be guaranteed for the optical properties can be guaranteed for 20 years,
Wow.
where other products can't offer something like that. And it's also a more rigid material than a polycarbonate. So you can see thick in extreme cases in very northern climates in Canada, you can see much thicker extrusions of an acrylic compared to a polycarbonate, which again helps a bit with insulation. So the transmission properties of acrylic are quite good, and the durability.
Awesome. Thank you for that. So, for my North American growers, acrylic is maybe an option to consider if you haven't thought about it before. Okay, so let's talk about SecondSky, and I'd like you to kind of talk about the history a little bit about the SecondSky material, and what makes it different and unique from these other glazing options that we've been talking about?
Yeah, so SecondSky was actually born in the infancy of what is now known as iyris or Red Sea. So it was born out of a research lab at a university in Saudi Arabia where Red Sea iyris spun out of. And the main goal of that research project was actually to study organic solar cells. So the Professor Baran, one of our co-founders, was actually looking to expand the absorption spectrum of typical solar cells to gain efficiencies in energy production. And what she developed, what she invented, was actually a nanomaterial that absorbs. So typical solar cells will actually absorb in the PAR because it's where most of the energy is coming from the sun, right? So she was trying to find something that would extend that absorption, taking it into the near infrared.
Oh.
So what and so what she found wasn't something that absorbed the entire spectrum. She found something that was transparent but absorbed in the near infrared. So the original idea of this nanomaterial that is now in agriculture was actually as transparent solar cells, where you're blocking near infrared, which generates heat, right? And you could apply this to a skyscraper, for example, or large glass buildings, and it has that triple benefit where it's transparent, so you can see through it, acts like a tint. It prevents heat from entering your building, and it generates a bit of energy on the side. And so that was actually the original intent behind the technology when it was first developed. But at the same time, Red Sea was starting to spin out from the university in Saudi Arabia, and the Professor Baran linked up with Ryan, who you know, a co-founder, and Professor Mark Tester, another professor at KAUST, and they joined this company that we now know as iyris, because Ryan and Mark said, like, if you can block heat without blocking PAR light, you're off to the races in agriculture. Forget about generating energy and adding this complete separate investment that solves a lot of problems for a lot of growers in hot climates. So that's when they teamed up and decided that together they could really make a company that could make an impact in ag tech, realizing that a lot of them had solutions that help solve some of the same issues.
That's really awesome. So, okay, so Second Sky has some nano materials in there, to block infrared light, but still allows the transmission of PAR. And so, like you said, this could be really revolutionary for controlled environment agriculture, for greenhouses, and even probably high tunnels, and all sorts of applications of these protective films and coverings. So tell us, we talked a little bit about, right, like light and heat, and the difference between PAR and infrared. So if we were to install a Second Sky material and compare it to, I don't know, maybe a double polyethylene or twin polycarbonate or something, like what are some of the differences that we might see, in the greenhouse environment, both in terms of light and temperature?
Okay. So first of all, I just want to state the fact that this isn't a separate product, right? So we're comparing to a standard double film or a standard polycarbonate product. The way that Second Sky products enter the market is actually through existing manufacturers. We only focus on the technology development and making our additive. It's actually key market players that are manufacturing the products and incorporating the Second Sky product into their catalog or into their product portfolio.
Oh, cool.
And so it's the same polycarbonate company making an iyris product or a traditional clear product. And the first thing we see is reduction in peak temperatures, right? So something neat about iyris that we kind of learned as we started doing trials is it removes a percentage of the NIR. So inherently, it works during the hours of highest, or works best or most efficiently in the hours or even seasons of highest radiation. And so it really shaves off peaks and helps control the environment during those peak temperature hours. When it comes to CEA, and I consider CEA something with an actual control system, we see gains in efficiency. So for you just have to work less to maintain those target temperatures, and to throw a number, between 15 and 30% savings on cooling just for switching the glazing.
That's a lot.
Especially in the Middle East, right? So in the Middle East, over 90% of your water consumption goes to cooling, and 10% or less is actually used for the crop. It's almost the reverse of Europe, where in the Middle East most people can grow in the winter. It's who can grow in the summer now when conditions are extreme. And so they definitely don't mind sacrificing a bit of par light for additional control.
So when you say 15 to 30%, so I mean, are you specifically looking at evaporative cooling technology? So fan energy and maybe water savings or pump energy?
Yeah, that's exactly it. I mean, it's
Okay.
mostly extrapolated from how much time the fans are on, and so then back calculating how much water is used. But it can be in the thousands of liters per day in some cases.
Wow. And what about temperature gradients, right? That's one of the biggest complaints people have about pad and fan cooling, right? Is that you get this temperature gradient from the pad to the fan. And something that always astonishes me, I don't know why I've done this, for 25 years now, but when you have a shade system, that temperature gradient really flattens a lot, because you don't have that heat gain as the air is traveling from one end to the other end. Do you see something similar with the SecondSky material? Does it kind of flatten that gradient a little bit?
Yeah, absolutely. So in the Middle East, in near Abu Dhabi, we actually built two polycarbonate greenhouses in collaboration with a produce association called Silal. And we built one traditional polycarbonate greenhouse and one with the iyris material. And so there we can almost semi in-house do these sorts of measurements. And what we saw is that in the summer months in the Middle East, you have a cooling pad, you're generating that evaporation, you're reducing temperature. But the gradient between the sensor, it wasn't even at the pad, but near the crop near the pad compared to the crop near the fan, the difference was 7 degrees Celsius. And which is a significant increase in temperature. And your crop management is identical for the entire greenhouse.
Mm-hmm.
And so with the SecondSky material, the delta was about 3.4 degrees on average. So reducing it
Wow.
by half with 5% reduction in DLI only. So yeah.
What was the distance from the pad to the fan in that greenhouse? Do you recall?
It's about 120 feet. I'll get the
Okay, so a typical
yeah,
length greenhouse. Okay. And so you said something about DLI. What was the reduction you said in DLI?
it would hover between 5 and 10%, maximum
Wow.
10%. Yeah.
Wow. So five or 10%, but your plants are a lot less stressed and probably using a lot less water as well, right? I mean, even on the irrigation side, not just on the evaporative cooling side.
Exactly. I mean, now we're dipping in a bit of your language, but by just simply reducing the degrees, slightly, you're affecting VPD if your humidity is the same. And so by lowering VPD in those peak hours, we're inherently using less irrigation. So even in a hydroponic system, you'll get less water consumption from the crop. It's not just in soil. It's not just about evaporation. You're right. You're right on it. The plant is actually consuming less of the fertigation.
Yeah. And now you have less stressed plants. And I would assume also more consistent uniform production within the greenhouse. If you have plants that are only exposed to a 7-degree Fahrenheit difference as opposed to a 15-degree Fahrenheit difference, I would imagine that all the plants coming out of that greenhouse, or the tomatoes or whatever you're producing in that greenhouse, are more similar to each other than without the SecondSky system.
Yeah, there's a whole nother world is crop management, but the potential to be more uniform is correct. And then, I mean, you speak to greenhouse growers, and they just want to extend. They can extend the amount of the length of the greenhouse and the volume in a specific area. So, I mean, there are benefits there. It just depends who you're speaking to, how they see it, or how they position it.
Okay, so we are humans and we're people, and we know that we're trying to create an environment for plants, right? I mean, but as a worker or as a visitor or whatever, right? You walk into a greenhouse and you're like, oh man, and you just start sweating, right? I always wear a ponytail. I don't worry about washing my hair before I do a greenhouse visit. So what does it feel like? Right? Like if I walked into a traditional greenhouse versus a greenhouse in SecondSky, does it feel different? Does it look different? What would I expect?
So visually, it stands out right away. So the SecondSky products have a bit of a blue hue to it. People think that we're adding blue color to the plastic, but that's actually a slight misconception. So it has a blue hue to it on sunny days. It's actually blue due to the size of the nanomaterial, something called the Rayleigh effect. It's the same reason why the sky is blue, and it's how the light is bouncing around within the material. So on cloudy days, it actually looks a little bit more gray, and on clear blue days, it'll be blue. Once you walk under it, you immediately feel a difference. So I mean, our bodies are walking sensors, right? And so it's a bit of an oxymoron, because oftentimes, I mean, we'll be in a polyethylene trial and you'll have a darker film, so you'll look at it and you'll see more light on one crop, but you walk under the iris and you just don't feel that radiation on your skin. And so something similar is happening with the crop. I mean, you asked, the previous question was about what do you expect. Typically, the first things that growers will respond with is actually the color of the leaf and the size of the leaf. So the crop is actually feeling a little bit more relaxed. We're almost tricking it to think that it's in the shade while still bombarding it with PAR is kind of the idea. But there's definitely a human aspect to it. When we were building those greenhouses in the UAE, all of the workers would take lunch in the SecondSky greenhouse, and they would have like rock, paper, scissors, shoot or something in the morning to see who would get to work in that greenhouse. And that's actually something we're actually in talks with a company now on quantifying. So we've had that anecdote of even my workers are happier under there, not necessarily productivity, but labor. Wow, that's becoming ever more important when we talk to growers.
Yeah, I mean, I've visited greenhouses where, especially in the southeastern U.S., where it's hot and humid. And I mean, workers are just, it's painful, right? Like they try to give them like ice vests or, cooling jacket, but then those are really heavy and they don't last very long. And the conditions can just be really, really challenging for people. And then if you think about plants, like the plants are exposed to that all the time. Like you don't get to give those leaves little ice vests.
That's the first I heard of an ice vest. I don't know.
Really?
That is the first I've heard of an ice vest. I don't know if I want to experience what it feels like.
Yeah, no, it sounds horrible, right? It's too cold at the beginning and then it's heavy and mushy at the end. I don't know. So you mentioned retrofitting greenhouses. So what are the various, I mean, is it a film SecondSky, or is it more of a rigid material? What is it exactly?
So we make the additive, and then we compound it into different plastics, right? So a net will use a high density polyethylene, a film will use a low density polyethylene. polycarbonate uses polycarbonate, and acrylic uses PMMA. And so we make the different master batches, and during manufacturing, it's actually mixed with the prime material. And so
Hmm.
the final product comes exactly as any other product. It doesn't the SecondSky additive doesn't affect any of the mechanical properties because it's added at such a low integration. And so we're really only optimizing the optical properties. So that it lasts exactly the same, it feels exactly the same. It has a bit of that difference in its visual appearance that I mentioned, but doesn't affect durability. It's compatible with all other additives and even in northern climates. So I like to specify near infrared, because the additives that maintain heat during the night are actually long infrared reflecting.
Hmm.
And SecondSky is actually transparent in the long infrared. And so it's also compatible for growers who are actually trying to maintain heat at night.
I was wondering that. What about UV or anything below 400 nanometers? Does it filter out any of those wavelengths, or are those still free to come through?
Those are still free to come through as far as iyris is concerned, right? So then it
Okay.
goes to the intrinsic properties of each one of the materials that we've been speaking.
Right. Right. And so you can embed or I guess blend in that nanomaterial into the properties. So it's not like you have a polycarbonate sheet and then you, I don't know, coat it or dot it or something with the nanomaterial. It's actually part of the, I don't know, the slurry of plastic, and
Yeah.
then it gets extruded into its form.
Yeah, I'm pretty sure slurry is the technical term for it because that is what it is. It's a mix of whatever you want to put in,
I know
and
too
then,
much. No, I
and then
don't.
you pump it through a machine, and then it, like you say, the final product comes out with it already embedded. It's not a post-manufacturing process, and it has variability in its integration. So when it comes
Mm,
to polycarbonate or acrylic, these are more thought out processes where we go into the sales process relatively early during the design phase, and we can kind of tailor each manufacturer each production run specifically to each grower. With polyethylene,
hmm,
where people want plastic immediately, what we did was standardize three different integrations because we're constantly saying that there's no silver bullet approach, right? Don't take
yeah,
European
yeah.
technology and put it in the hottest part of Mexico or Texas or Florida. And so to not fall into that same grouping, we do three different integrations. So our par transmission varies between 87 in a very high transmission product to 75%. And so for polyethylene products, we do three standard integrations to have that variability for crop and geography.
Interesting. So are you saying that if you're just replacing your polyethylene film, or that's what you want to go with because you're kind of looking for sort of a lower cost glazing, or you have a hoop house or something, that you have these kind of three standard options that, or four, I guess you could say, one without, and
Yeah.
then the other three percentages depending on how much light you want to bring in, or considering that trade-off we were talking about at the beginning between heat and light. You're like, well, it's not so hot here. I like the idea of blocking some of the heat, but I'm more interested in bringing more in the light. So like you can make those decisions. But when it comes to polycarbonate and acrylic, did you say that you custom extrude those or custom blend those for the client?
Yeah, exactly right. So for
Hmm.
where I mentioned in the Middle East, right? So we've done some polycarbonate projects in the Middle East. It's a very high integration because they could not that they could care less about the winter, but their main focus is summer production where it's 110 degrees with 80% relative humidity, right? And so they'll shade a lot more than the polycarbonate that we made for a citrus nursery in California. where
Yeah.
the citrus, the radiation levels are different. Citrus likes a lot more light. So we were able to reduce PAR by only 3-4%, for example. So
Interesting.
we work directly with the manufacturer and basically give them the recipe and they can pump it out. So it's
So are you working directly with customers then? Like do those greenhouse growers come to you and say, "Hey, we're interested in your material. This is our location." And do you help them make those decisions, or are they making those decisions? Are they hiring someone like us to help them make those decisions? Like, how does that communication happen?
yeah. So
Or maybe it's all of the above.
well, if we stick to it's always it's always on a
Yeah,
spectrum.
yeah.
It's always all of the above. In polycarbonate projects, it's typically people like yourselves or even greenhouse builders that we interact with. So it's more on the design. They have an idea of what the customer wants, what the crop requires, and we try and get to a point where it checks all of the boxes. In polyethylene, we interact a lot more with the end customer, and
Hmm.
depending on their current situation, we guide them towards a certain solution. So with the same products, depending on what they're doing, the framing of iyris SecondSky is heat blocking, right? But it can be heat blocking, it can be light enhancing, or it can be both, all relative to what the control is, right? So what the grower is now using. If they're using a 25% shade plastic, we can offer them the same heat blocking, but with more light. So that's why sometimes it can be light enhancing, sometimes it's heat blocking. It depends on the objective.
Is there such thing as too much sunlight? Like in Saudi Arabia, like I mean, maybe you want to block more light because you just don't need that much light? Has
I
anyone ever said
I
that?
mean I'm not going to be I'm not the plant expert here. As you mentioned in the intro, my background is more on the engineering side, and I'm
Yeah.
2 years into the industry, but it's ridiculous the amount of variability between crops and even the same crop, even just varieties.
Mm,
So yes, of course, there's many crops that don't need a lot of par. More par does not always equal more light, even if the rest of the conditions are the same. And we've seen cases where crops get photosaturated. So
sure.
yes, there's sometimes an excess of light.
Okay. Fair enough. Fair enough. So does the Second Sky product last longer than some of our traditional materials? I don't know. I feel like maybe it could extend the life, or maybe it could shorten the life if it's absorbing some of the wavelengths of light.
It's a great question, actually. So we started with acrylic, right? So our first integration was actually, let's go for the highest value products because the price difference will be minimal. That was kind of the idea.
Oh, nice. Okay.
And the most technified, so people that are already investing in additional technology. And so we're a brand new company at the time. There's no way to test something on a product that's guaranteed for 20 years. So we did what we had at our disposal, the best we had at our disposal, which was accelerated tests, which coincidentally is what they use in the solar industry. So we use the same process to determine the durability of solar cells, but with our additive. And what we saw was that the SecondSky additive degraded slower than acrylic. And so when it comes to the other plastics,
Hmm.
we know that our additive itself will not degrade. Now, how it affects the plastic in terms of its guarantee. So one piece is the nanomaterial degrading itself, and then the other is how it affects the actual plastic. And like you say, it actually does absorb the near infrared. So the glazing material will actually heat up a bit more under with a SecondSky product embedded than a standard material. What we say is it maintains the heat at the glazing rather than letting it enter the structure. Um, in most cases, the so this could affect the mechanical properties, but in most cases, polyethylene, polycarbonate, they're guaranteed for their optical properties rather than necessarily their physical ones.
Mm,
When it comes to polycarbonate, the degradation is mostly governed by UV, which is determined by how thick your UV protection layer is. So it could be 5 years, 10 years, 15 years, depending on what is ordered. And something very similar in polyethylene. And so the temperatures that we increment to aren't high enough to affect the physical properties of the material. So we haven't seen them, disintegrate during a trial or break prematurely due to the additive. So we haven't seen anything like that, luckily. But I do mention that we are a young company, right? So we started 4 or 5 years ago, and some of these products last longer than that. So
sure, sure.
what we've seen in polyethylene, which does have a shorter cycle, for example, we haven't had those issues. Yes, it's true, it does heat up, which can make it a little bit more flexible at times. That's something to manage, but nothing significant in terms of the durability.
Interesting. So just sticking with glazing in general, are there other innovations or trends that you're seeing in greenhouse glazings? I know, there's like solar glass. You guys are doing like the photo selective
Mm.
glazing. We see various coatings or additives. We see different additives in different materials. But is there anything else? I mean, it's really exciting what you guys are doing, but are there other innovations you're seeing in glazing? Because I mean, it's just been the same thing for a really long time. So I personally am really excited you guys have sort of stumbled upon this new opportunity or this new innovation. But I'm curious what else you're seeing out there that could stick or help the industry advance.
Yeah, I think it's actually like you mentioned, it's a super exciting time for glazings. For a long time, glazings were treated as a commodity, and
Mm,
everybody's looking at basically everything else. How do I, stimulate my plant with different fertilizer or with different substrates, or how can I gain efficiencies with hydroponics or cooling
right.
systems? And everyone's forgotten to look up, right? And so that's what we're seeing is people are just taking what's on the shelf. But there are of course other innovations in the market. The guys at Ubiquity are famous
Mm,
for photo selectivity and playing with the spectrum of light using quantum dots and shifting radiation from one portion of the spectrum to the other, which is similar but also very different to what we're doing, and a lot of experimenting with colors. I see this a lot
yeah.
in net, for example, more than a polycarbonate or even a polyethylene film, around pest pressures. So there's been, some studies in red net that have reduced thrips, right? And
Yeah.
not all 100% understood, but it's exciting to know that people are starting to look up again, and there's many things happening in the market around that, and finally making it crop specific. I mean, we work a lot in berries, and I'm tired of hearing the word berries because a blueberry has nothing to do with a strawberry, right? And
Oh,
so
yeah.
um, so the requirements are different. And so I'm starting to see that where people are actually starting to now separate glazings depending on geographies and crops, which is
Hmm. Yeah, I agree. Yeah, the red netting thing is really interesting. Well, I was recently in Japan and we saw a few red netted houses, and we were talking about, nobody really quite understands why it
yeah.
seems to confuse thrips. It's Dr. Cherry Kubota, she mentioned that one that some scientists think that it kind of creates like a black void. So it kind of just looks like there's blackness in front of them and they're like, I don't want something black, right? I'm looking for something green. So yeah, it must shift the color that they're used to seeing or something. I don't know. So what do you think about ETFE? I hear that kind of I feel like some people are really excited about it, but it seems really expensive and it stretches a lot, but maybe has some good properties. Do you think that ETFE has a chance to be in the future mix of glazings?
I do. I
Oh,
do. And we don't work with ETFE yet, but I can't wait till the day that we do.
okay.
Because we do sacrifice a little bit of par, as I mentioned, right? So at least 2, 3, 4, 5%. ETFE, the benefit that it offers is the transmission.
Mm.
It's essentially not there. It's above 90% transmission. It's very durable. It's a great product if you want lots of light. The challenge that ETFE has is almost the same as glass, where it's very hard to incorporate additives because it's a fluorinated compound. And so
Oh.
there's this bit of a technological step that we need to get on top of, which is how to efficiently add additives during the standard manufacturing process. So there's, like most technologies, there's always a place for something with beneficial attributes, like the transmission and durability of ETFE. But I've yet to see a company or a manufacturer able to seamlessly add, thermic or antithermic or diffusive additives to ETFE.
Yeah, yeah. I'm really glad that you mentioned that you're happy that people are looking up and around. Because I agree 100% with that. You've used the term a few times, protected agriculture, which I have started shifting my terminology to protected agriculture more and more. It seems to just cover a greater sphere of what controlled environment agriculture is, even if you don't have control, right? We're protecting our crop, even say in a high tunnel, or for germination or for certain specific things. But that is the first line of defense, right? Is the shell, are the four walls and a roof, just like our home, right? Like, it's shelter. You start with the shelter, right? Then you build within it what the environment that you try to create. But first, we're trying to keep the environment out that we don't want and bring the environment in that we do want. And that shell, that cover, that glazing, those walls, that roof, whether you're in a building or in a greenhouse or whatever, is really your first line of defense. And with a greenhouse, the benefit, everybody if you're in a greenhouse, it's to use the sun, right, to your advantage. And so finding ways that we can protect our crop from not just wind and rain and hail, right, and the super extremes, but to find a way to use it to also help manage your thermal environment and bring in light is the innovation that we need in this industry. And there's, I mean, you can't just do like you do in a building, right? I mean, our values, right, requirements, regulations have increased so much over time. And if you're in California versus Canada, the R value requirements are hugely different because we don't get super cold here in California. But if you're in Michigan or Canada, you do. And so you need thicker walls. But that's not so easy with a greenhouse, right? We have single layer something, we have double layer something, or twin wall something. And, some people promote triple glass, which I just think is insanity, for a million reasons. I can't think of a good reason
I'm
personally.
glad we're on the same page with that one.
Yeah, it just dumb. I'm just going to say that. Um, but that leads me to my next question, or just kind of piece of the conversation here, which is California's new energy code. You mentioned before we got on the podcast that was one of the first podcast episodes that I did that you listened to about the new regulations. And, you know, one of the new regulations is to have multi-layer glazing for a greenhouse, right? No longer can you have single poly film or, corrugated polycarbonate, which, by the way, I'm also not a fan of those of those solutions either. So I'm okay with going to double layer something. But also in some ways it feels misplaced, a misplaced regulation in California because we don't have super extremes. But I'm curious, because I mean, how does Second Sky kind of respond to that? I mean, it seems like since you can integrate into the existing materials, you can meet, right? Like your materials are not competing against that regulation, right? Because you can buy a twin wall polycarbonate with Second Sky integrated into it, or right, two sets of film with that.
Yeah, that's right. That's right. And I mean, you say misplaced, but these kinds of things are needed for ultimate sustainability, which is,
Mm,
to maintain a certain geography productive if it's an ag region like California is. The reality of California is, that it's not a perfect place to grow crops. They do have a water issue, for example, right? And so whether you're controlling your environment to add heat in the winter or cool in the summer, though those are external resources that you're pulling from somewhere to invest into your structure, right? And so it is the responsibility of technology providers and agriculture as a whole to operate within those regulations and guidelines. And actually, we see this as a benefit for what we're trying to provide, right? So more insulation, more control is what we preach. We work with double polyethylene films that their main goal is to maintain heat in the winter. The reality is that in the summer they're again shading to reduce heat, and so in very few cases do we see that I mean, Canada is maybe not our target market, but in most cases, even though you're heating in the winter, you're also cooling in the summer. So added control is what we're all about. Yes, it limits some projects in terms of, single layer polycarbonate, single layer polyethylene film in controlled environment spaces. I mean, there's still the whole market of naturally ventilated systems in high tunnels where this is
mm.
not necessarily applicable. So I think it's actually a step in the right direction in tightening those regulations, because CEA as a whole is very good at pointing out savings in irrigation.
Right.
They don't like to look at full life cycle analysis of their water use, right? And so it almost levels the playing field with, across agriculture. We can call it open field, protected, and controlled environment.
Yeah. And I'm curious. Well, a couple things just on the energy code real quick, in sort of advising to them in the capacity that I was able to when they were setting up the regulations and deciding what to include or not include in the code. Um, we talked a lot about shading and how that, especially in, hot sunny climates like we have here in California, that has potentially more benefit to energy savings than, having a double layer, you know, U factor that's, incrementally better, having two pieces of plastic rather than, you're not insulating your walls or anything. Um, but the regulators are really hesitant to mandate something that is user dependent, right? And so they see a shade screen as something that depends on the grower, the operator, the farmer to actually deploy, right? To actually use to save energy. And of course they're going to use it because they're thinking about, their crop and right, and they don't want to stress it out, and they are they have limitations to their cooling system. But it seems like Second Sky is that opportunity to have something integrated into the building infrastructure of the greenhouse that is not user dependent, right? And still would still have more advantages than our conventional, double layer anything.
I mean, it's all additive. It doesn't always have to be, one or the other.
Hmm.
And we've done that. We've done tests with a single layer versus a double layer. We did it in Yuma, Arizona, another, very hot climate.
Yeah.
We we saw more light and less temperature. So to your point, it was actually able to insulate because these houses did have, pattern fan system. It was able to maintain a cooler environment, even though it only had one film. Um, Compared to the double layer, and it was letting in more light. So it's a bit of that oxymoron again, explaining to how
Hmm.
second sky works. And so while we would love to argue that case, and that you can use single layer as long as you use our additive, it still helps, right? So a
Yeah.
double layer using second sky would even be, better at insulating that temperature. And so we're not trying to fight regulators and regulations. It's how we can use them to actually help growers achieve their targets.
Yeah. So, you said something earlier that's a good segue into my next question, which is, a lot of people like to tout the benefits of reducing irrigation water use, but very rarely are people thinking about the water use of evaporative cooling. And for me, that was my aha moment when I was doing my PhD at the University of Arizona. Was nobody was talking about the complete water balance of the greenhouse. Let's find out how much water we use for evaporative cooling. And all of a sudden, it was not so positive of a message.
Yep.
So, being somewhere like Saudi Arabia or even Yuma, Arizona or California, right? I mean, we are so water stressed
Yeah.
right now, everywhere you go, especially where evaporative cooling actually works, right? There's a reason it works well there because it's dry, there's not a lot of water. So, I mean, I'd like you to just touch a little bit on the desiccant cooling system that you guys were developing at Red Sea. And, you know, just kind of that combination of using a system like Second Sky to reduce the heat stress, reduce the irrigation water use, but then also be able to simultaneously reduce your cooling need and the evaporative cooling, not just energy use, but water use.
Yeah, sure. So this was also exciting. So I mean, back to the birth of the company, right?
Yeah.
So there were three main co-founders that started the company. One was Professor Daria Baran, and we've spoken at length about her innovation, which is the Second Sky additive. We have Professor Mark Tester, who's a well-respected professor in the plant science. He's dedicated a career to salinity tolerance of different crops.
Mm,
He actually has another product that is in our pipeline, which is a salt tolerant tomato rootstock. And we're doing
nice.
very interesting trials in North America, South America, and actually Europe as well. So that was one technology. The third technology was Ryan's, which was a desiccant cooling system, right? And the idea of all three of the technologies is actually to reduce the input in agriculture and CEA specifically, by reducing water requirements or increasing heat tolerance in all of the technologies. In Ryan's case, the desiccant systems, it tackled the biggest pond there was in terms of water consumption, which, as you know, is the cooling system. And not only in terms of water consumption, but manipulating your external environment. So in Saudi Arabia, we had the interesting case where you have no water, but it's not dry. So near the coast at night, you'll be at 85 to 95 degrees Fahrenheit outside with no light and 80 to 90% relative humidity some days, like ridiculous. It's
Ick.
the windows on the buildings are condensing all around you because of the air conditioning.
Oh my
It's a
gosh.
very humid environment. And so what Ryan was able to develop during his PhD and as a postdoc and a research scientist was a cooling system that works off of a desiccant. And traditionally, people think desiccant of what comes in their new shoes, right? These little pellets
Mm,
to prevent odors. Well, if you dissolve salts into what desiccant does is it sucks humidity out of its environment, right? So it's a humidity absorber, if you will. Liquid desiccants are essentially very highly concentrated salt solutions, and through osmosis, it sucks humidity out of the environment. And so what Ryan was able to develop was a system that was able to reduce that humidity from the extremely humid air before it hit a wet wall to increase the efficiency of that evaporative cooling system in a very humid climate. That was the first generation of the desiccant systems, and when we started to think about cooling systems don't work the same everywhere, right? So that was a product in and of its own. Separately, we developed a cooling system that actually runs completely off of salt water. So not going all of the way of a desiccant and removing humidity from the air, but what if we could evaporate salt water and not use any fresh water, right? So in the Middle East, 95% of all the water that is drank or used in agriculture is actually desalinated. So it's an extremely energy intensive process. It's an expensive commodity. It's not just pumped out of the ground. And so access to salt water is not something that they struggle with. And so the cooling system technology, which is in our pipeline, but not a primary focus, has those two avenues to explore. One is not controlled environment within the greenhouse, but actually controlling the environment before it hits the greenhouse. And then the other is removing a precious resource from the operation, which is fresh water.
Does that evaporative cooling process or using that salt water, can that be used as an initial step to desalination?
Yes, I mean thermal desalination is a thing, right? It's essentially distillation. Speaking about the saltwater evaporative cooling, right? So we replace fresh water with salt water, and what it's evaporating is essentially pure water. If you distill that, you could generate fresh drinking water. There's no reason why you couldn't. What's left though is a nasty brine, right? So in some cases, like in California, you'd have more issues on waste allocation rather than water production.
Yeah. I mean, how does that affect the materials used for evaporative cooling? I mean, we see calcium deposits all the time, right, on wet walls that are left behind after the water evaporates. I mean, did you have to consider different materials for that wet wall so that they were maybe less susceptible to to those deposits, those salt deposits?
Absolutely. And that's exactly what anybody can put salt water into an evaporative cooling system. That's not necessarily innovation. Where we came in was around the sensing to make sure that we weren't reaching that crystallization point. And so we're constantly monitoring the water quality, the electrical conductivity of the water to make sure that we're not getting to a point where it's damaging the traditional pad. So in terms of material selection for the saltwater evaporative cooling, we did go through a couple of iterations. We tried cardboard pads, we tried polypropylene pads, because even if you do smart sensing, so our bit of IP is not using, putting salt water into the system. It's making sure that it doesn't crystallize and damage the pad. And so the first thought was to switch the cardboard for something more robust, something like polypropylene, which is a plastic, and every so often you can just rinse it down and get rid of those salts. What we found though is that it wasn't as efficient as a cardboard pad. So cardboard pad offers cooling efficiency, which is not something that you can necessarily reduce in a place like the Middle East. And so we stuck with the cardboard pads, and then comparing their cooling potential. What was, a nice surprise was actually that the cooling efficiency didn't change at all. What we do have to do is manage that water, as you allude to, making sure that we don't damage the pad and reduce that efficiency. But we do that very carefully. So we're constantly monitoring the water quality, the electrical conductivity, making sure we stay as far away from that crystallization point as possible.
That's
There
so
are, of course,
interesting.
yeah, of course, it does crystallize a bit when you're evaporating water from a salt solution. You'll have some deposits, so it's just about monitoring that, making sure you backwash, you clean the pad regularly.
Does the temperature of the water make a difference in that crystallization?
For sure.
Yeah.
For yeah, for sure. For sure. Solubility and temperature
Right,
are directly correlated, as you know.
for sure. So, you know, just to kind of start to wrap up here, I mean, what innovations or technology developments are you hoping to see in the greenhouse world, especially around cooling? I mean, we've talked about glazing and the innovation, some of the stuff that's happening there, and the desiccant cooling or saltwater evaporative cooling system. But where do you see the greatest need? Where are you hoping to see new innovations?
Yeah, I mean, it's a great question, and yeah, I mean, in terms of technology, I would like to see more tailored designs. I know you had Quarantine from Arnois here talking about tropical greenhouses, and that's the exact kind of thing that I'm talking about. And
Yeah.
not just from structure, but material selection into that structure, how we pull information to the grower. I think the next big leap in agriculture will be intrinsically linked to information to growers. So I think the vast majority of even protected agriculture, the growers are not necessarily informed on the benefits of the different products. And so I think it's at where we know that we're in the information age, and I think it has to focus on resources. So it's hard to say that it has to come from any given sector in the ag tech space. I think the real push will come from help from everybody, right? So the quicker that we all learn that we're all pushing towards the same thing, the better. But I think it's all about resource management. We know that, we have more and more people to feed every single year. So I think the technologies that focus on a holistic approach of resource efficiency for production, so production normalized by what you're putting in, which is how we should be looking at things, is what's going to take agriculture to the next level and make sure that we can feed the 50, the 10 billion people by 2050.
Yeah. So thank you for the plug on more tailored greenhouse designs. And I say that because that's
Okay,
exactly
okay.
what we do. And I kind of want to ask you, push you a little bit on that, which
Okay.
is why do you think greenhouse growers are not opting for tailored designs? Why are they going for these standard designs or even these now, imported European greenhouse designs as opposed to, right? Like looking at each system independently and creating a custom package solution. Do you have any thoughts on that?
I would love to put all the blame on the greenhouse builders and designers, but the growers bear a huge amount of responsibility here as well, which goes back to the technology providers to educate the growers. I think there's a big lack of regional education of what is needed in specific regions. So I think it's actually a grassroots issue because it's really the grower that tells the greenhouse builder what they want, and they've heard that in Europe this design is great. So why can it not work in Sinaloa, Mexico? I mean, I've seen, it was 98 degrees outside, and I was standing in a greenhouse in Mexico that didn't have any vents whatsoever. And so
Yep.
you wonder how that came to be. And the blame doesn't go to any one person. I think in terms of a sales cycle, it's much easier to sell a commodity, something that's on the shelf, as well. It's, it's something that you've sold. You have examples all over the world where this has worked. It can work for you as well. There's a bit of that. It's a lot simpler to have a turnkey solution than to take a greenhouse which has so many moving parts and look at how to optimize for each one, which irrigation system, which control system, which glazing. It tends to be time consuming, which is not something that everybody has, a lot of. Everybody has a bit of the blame. The technology provider to the greenhouse builder, the greenhouse builder itself, and the grower as well.
Yeah, and I think, your comment about needing regional education and also greenhouse growers not necessarily being informed about the benefits or the usefulness of some of the systems that they're being sold or told they need or told they don't need, or, I mean, it happens in commercial buildings too, where a lot of times, the engineers and the designers and the architects, they've designed a what we think is like a perfect system, right? And then, the builders build it and then they hand it over to the owner and it's like, well, what do I do with this? So, yeah, I mean, I think you're right about who's to blame, and it's not really blame, it's just that it's because it's such a burgeoning industry right now, especially in North America. People are realizing the value and the future benefit of this. There just isn't, we just don't have the historical knowledge, I guess, here in the US, especially in the new regions where we're growing, like we do in Canada or in Europe. And I've heard, some people make that comment as well, like greenhouse growers just they don't know, right? And if you don't know what you don't know, then you have to rely on others to tell you. So that
And
can
sometimes
also,
the right solution, yeah, I mean, sometimes the right solution isn't sexy, right? So a glass greenhouse,
yeah, yeah, right.
it looks awesome. A 95% transmission ETFE film looks amazing. But no, I mean, I've yet to find someone to explain to me why, in high tech, high temperature regions in Mexico, people are still using a 90% transmission film and then painting the top of their greenhouse, 8 to 10 months of the year to just have it, unpainted for 2 months, where even washing off the paint, you're reducing your par. But a diffuse white film doesn't look as sexy as a clear one that they use in Spain. So I think it's a bit of both, and I do
Yeah.
see changes happening in the market, even in the last 3 to 4 years.
For sure, for sure. I like that you brought up the sexiness because, those high bay, glass houses, they're beautiful,
They are.
right? And we've had a lot of free money, so it's like, oh, just put as much money into whatever this is, right? This vertical farm or this high-tech greenhouse without ever asking the question, right? Like, is this necessary? Like, what can we cut out? What do we need, right? How does this differ for our crop, for our market, et cetera, et cetera? Yeah.
Yeah, you're right on.
Sometimes it's better to be lean, right? You'll ask more of those
Uh,
questions. So, Nico, from your perspective, it's fun to talk to another engineer. What do plants crave from greenhouses and greenhouse technology?
they crave a comfortable environment, right? And the trick is that varies for every single crop and every single variety, right? So it's finding what that comfortable environment means for each crop or each region, trying to generalize it as much as possible to not drive yourself crazy, but still maintaining enough specificity that is optimal for that potential client, let's say. But for crops themselves, they want exactly what humans want. They want an environment where they can thrive. They don't want to be stressed out, and they want it for as long as possible. So as long as we maintain them within their thresholds, they will in turn give us what we want.
Awesome. So, all right. So that concludes all of our official questions. So now I'm going to ask you a handful of rapid fire questions that are meant to be quick responses. If you want to expand on one, you can, but they're just meant to be quick. All right. Are
Brilliant.
you ready?
Let's go.
All right. Are plants introverts or extroverts?
Introverts.
Okay. What is one piece of advice you would give to a greenhouse grower trying to decide on what type of glazing material to use?
Know your radiation levels during your target crop cycle.
I like it. All right. What have you learned from plants?
Their infinite complexity. Their infinite complexity. How switching just a little bit of radiation, the cascade effect that it could have on everything, on absolutely everything.
That is a very good answer. What will we be growing in greenhouses in 20 years that we aren't growing now?
Row crops. Row
Row
crops.
crops,
Yeah.
like cereal crops?
Like cereal crops, like soy, things that you traditionally see in large fields. I think the globalization of those crops will diminish over time as well.
I tend to agree with you. I know there's a lot of people out there who say cereal crops, right? It could never be efficient. It could never, right, work. But I mean, we have all these limited resources and our soils are not in great health and we don't have a lot of water. I mean, it makes sense to me that at some point there's going to be a crossover.
Exactly. So it's not gonna be the bulk of that production, but we're gonna start to see it in certain areas. I think. I see new crops undercover all the time. Recently involved in a project where a guy wanted high tunnels for broccoli. It was, my first case seeing protected agriculture with broccoli. So I think a lot of these large scale crops that we're used to will find their niche under some sort of protection.
Yeah. What do you miss about living in Saudi Arabia?
The research. I miss the research and the cultural experience. So I lived 5.5 years in Saudi, but it wasn't really Saudi. So we lived in like what we call almost like a little oasis in the desert, which is KAUST. It was a graduate university, 100% dedicated to research. So no undergraduate research with 115 different nationalities, right? And all of that with less than 10,000 people. So it was like a academically stimulating experience, even, going to get a coffee because you never know who you would run into and what their research focus was. It was KAUST was a very, very unique experience. I do miss KAUST a lot and the people. I think the people were the biggest surprise to me. They get positioned as this like completely different world, whereas you quickly realize that everybody has the same issues when it comes down to their day to day.
Yeah, we are all humans
Yeah.
after all, right? Yeah.
Some of us trying to
Struggling
grow.
through our human condition.
Yeah, exactly. No, it was surprising like how open and how excited they were to show a foreigner their culture. Like they almost get positioned as xenophobic. And it was I found exactly the opposite. It was yeah,
That's
quite eye.
awesome. What about
Yeah.
the food?
The food is, yeah, it seems like the easy answer, but yeah, number one, definitely up there. I'm still making my hummus and my mutabal at home, which is like a hummus made from eggplant. Yeah, I mean it would some people see it as a negative that you don't see, great Italian food or great French food or even, different cuisines, Mexican food in Saudi. It forces you to eat the cuisine, which, luckily for me, I love it. So yeah, the food is absolutely great.
Yeah, I would agree. And matubble is near and dear to our
Oh,
hearts. So
none of the best. It's the best. It's even smoother than a hummus, a little smokier.
it is.
Love it.
Yeah. When it's
Absolutely.
done well, yeah, hummus. can't compare for sure. Well, Nico, thank you so much for your time today. It was really great to talk about a topic or a system within the greenhouse that so many people overlook or at least take for granted, right? It's nobody, we were talking about sexiness of a greenhouse. Nobody talks about, right? What's sexy about the glazing, except maybe it makes a good photo from the outside on day one before it degrades over time. But other than that, it's everything else that growers tend to focus on. So thank you for focusing on that with me today.
We're bringing sexy back.
I like it.
Awesome. I can't thank you enough for letting us come on your platform, and thank you for all that you do in this space. We touched on education in the sector, and love the way you highlight that, not just in things like this, but conferences. It's always a pleasure to interact with you.
Thank you so much. Well, have a great rest of your day, and thanks again.
All right. You as well. Have a great weekend.
You too.
Bye.